Ever wondered how software is developed? Well, there are several models or approaches utilized in the software development process. Imagine you're building a skyscraper. You wouldn't start by adding the top floor, right? You'd begin with a solid foundation and work your way up. This thinking is what underpins the concept of software development models, which provide a structured approach to creating software, much like an architect's blueprint for constructing a building. In the world of software development, two prevalent models are often used: the linear and iterative process models. These models, while sharing the same ultimate goal of creating functional software, differ in their structure, planning, and adaptability. The linear model, also known as the waterfall model, is like constructing a building floor by floor, with no going back once a floor is completed. It's a sequential approach where each phase must be completed before moving on to the next. On the other hand, the iterative model is more like sculpting a statue, where you can continuously refine and make changes until you're satisfied with the final product. It's a cyclical process that allows for continuous feedback, adjustments, and incremental improvements. Choosing between these models isn't a matter of right or wrong, but rather, it depends on various factors like project requirements, team dynamics, and client expectations. Let's delve into our first model, the linear or waterfall model. The linear process model, often known as the waterfall model, is a sequential approach to software development. This model is characterized by its strict structure, dividing the development process into distinct sequential phases. The key stages include requirements analysis, design, implementation, testing, deployment, and maintenance. Each phase must be completed before moving on to the next, ensuring thorough documentation and planning at every stage. This well-defined structure provides clear milestones, making it easier to track and manage the project's progress. Now, let's walk through a typical workflow of the linear process model. It all starts with a requirements analysis, where the team gathers and documents the requirements from stakeholders. Once the requirements are clear, the design phase begins. Here, the system architecture is created, including data structures, components, and the interactions between them. Next is the implementation phase. In this stage, the code is written based on the design specifications. After the code is written, testing is conducted to ensure the software meets requirements and is free from defects. If the software passes the testing phase, it's time for deployment. The software is delivered to the users and deployed in the production environment. Finally, the maintenance phase addresses any issues or changes required after deployment. The linear model has several advantages. Its clear structure makes it ideal for projects with well-understood requirements. Each phase involves detailed documentation, making it easier to understand and maintain the software. Plus, the progress is easy to track, and each phase has clear completion criteria. However, the linear model also has some disadvantages. Its rigid structure makes it difficult to adapt to changing requirements or unforeseen issues. Also, testing occurs near the end of the process, making it challenging to address major issues without significant rework. Lastly, projects with evolving or unclear requirements may struggle with the linear model. While the linear model has its merits, it's not always the best choice for every project. This brings us to our second model, the iterative process model. The iterative process model, often exemplified by the spiral or agile models, focuses on repeating cycles of development. At its core, the iterative process model is built around cycles. Each cycle, or iteration, dives into a subset of the overall project, delivering a functional increment of the software. This allows for continuous development, testing, and refinement. It's like creating a sketch, then revisiting it again and again, each time adding more detail and depth until you have a fully realized masterpiece. The typical workflow begins with the planning and requirements analysis stage. In this stage, the team identifies a small set of software requirements to work on. The designers then create a software design, and developers bring that design to life in the coding phase. The software is then tested and any defects are fixed. But unlike the linear model, this isn't the end. Instead, the team goes back to the planning stage, bringing with them the lessons learned, and the cycle begins anew. This cyclical nature is one of the iterative model's key strengths. It allows for continuous feedback, both from within the team and from external stakeholders. This feedback can be incorporated in the next iteration, making the software more robust and better suited to the end user's needs. It also allows for early testing and validation, catching potential issues before they become major headaches. But the iterative model is not without its challenges. It requires a high level of discipline and communication within the team, as the scope of each iteration must be carefully managed to avoid scope creep. It also demands more resources, as each iteration requires its own round of planning, design, coding, and testing. And while it is more adaptable than the linear model, this flexibility can lead to uncertainty, as the final product isn't fully defined at the outset. The iterative model offers a more flexible approach, but it also has its own set of challenges. While it allows for continuous improvement and adaptation, it requires careful management and clear communication. But when used effectively, it can deliver a software product that truly meets the needs and expectations of its users. Now that we've understood both models, it's time to compare how they stack up against each other. Let's begin with structure. The linear model is characterized by a strict sequence of phases, with no overlap or backtracking. Once a phase is completed, you move on to the next, like stepping stones across a river. On the other hand, the iterative model is more akin to a spiral staircase, where each step represents an iteration that includes all the phases of development. You keep circling around, building upon the previous steps with each new iteration. Next, we look at planning. The linear model requires extensive planning up front. It's like building a house. You need a detailed blueprint before you even lay the first brick. The iterative model, however, encourages adaptive planning. It's more like sculpting a statue where the overall shape emerges gradually as you keep chipping away at the stone. When it comes to adaptability, the linear model is a bit rigid. Changes are difficult to accommodate once the project is underway. It's like a train on a set track. It can't easily deviate from its course. The iterative model, in contrast, is highly adaptable. It's like a car on an open road. It can change direction at any turn, responding to feedback and evolving requirements. In terms of risk management, the linear model can be risky. Since testing is done towards the end, any significant issues can lead to substantial rework. It's like baking a cake. Once it's in the oven, you can't change the ingredients. The iterative model, however, mitigates risk by incorporating testing and feedback at the end of each iteration. It's like cooking a stew. You can taste and adjust the flavors as you go along. Lastly, let's consider client engagement. The linear model involves the client primarily at the beginning and the end of the project. It's like watching a play. You see the curtain rise at the start and fall at the end. In the iterative model, the client is involved throughout the process, providing feedback after each iteration. It's more like a rehearsal. The client sees the performance evolve and refine over time. As you can see, each model has its strengths and weaknesses. The choice depends on various factors such as project requirements, team dynamics, and client expectations. To sum it up, selecting the right software development model is a critical decision that can significantly impact the success of a project. These models, linear and iterative, each come with their own set of strengths and weaknesses, making them suitable for different types of projects. The linear process model, also known as the waterfall model, is a sequential approach where each phase needs to be completed before the next begins. It's like taking a step-by-step journey down a waterfall. This model is favored for its clear structure, thorough documentation, and well-defined milestones. It's especially effective for projects with well-understood requirements and where predictability is valued. However, it's not without its drawbacks. Its rigidity can be a disadvantage when dealing with changing requirements or unforeseen issues, and testing near the end of the process can make it challenging to address significant problems without substantial rework. On the other hand, the iterative process model, often seen in spiral or agile methodologies, is all about repetition and refinement. It's like taking a scenic route, where you revisit certain areas multiple times, each time gaining a better understanding and making incremental improvements. This model excels in its adaptability, continuous feedback, and incremental delivery, making it suitable for projects with evolving requirements, or where innovation and flexibility are key. However, it requires a high level of communication and can be challenging to manage due to its less defined structure. In essence, the linear model is akin to a well-planned point-to-point journey, while the iterative model is more of an exploratory adventure. The choice between them depends on various factors such as project requirements, team dynamics, and client expectations. Remember, there's no one-size-fits-all model. It's about choosing the right approach for the right project. Thanks for watching, and stay tuned for more insights into the world of software development.